This is going to be going over the second part of the first section. So we already talked about some parts of radicals. We simplified some radicals. Now we're going to look at rational exponents, which this will make a lot of sense after you've done it. But at first it's a little weird. So say that we have the exponential form of a to the 1 over n. So when we have that set up, we can actually rewrite this as the square root of a, and whatever the denominator of that fraction is, that becomes our index. So say, for instance, we had, 2 to the exponent of 1 over 2. We would rewrite that as the square root of 2, and our index would be 2, so we would just leave it as the square root of 2, which we'll look at some examples of this. But it's pretty much all that's saying. That's just a very general way of putting it. Now, that is the form when we just have our, say, for instance, we had 4 to the 1 over 2. So when we have that set up, we would just write it square root of 4. Say that we had the square root of, or we had 4 to the 1 over 3. It would just still be the square root of 4. Now that denominator of 3 would be our index, so it would actually be the cube root of 4. So that's all that first part's really saying. Now we're going to look when that fraction that we have is not just 1 over something. So if we have that number be something other than 1, we denote that by saying m. So if we want to rewrite this as a to the m over n, we can rewrite that as the square root of a, or just radical a, to the m power, and that index still is going to be to that n. So let's look at some examples of that, because I'll show you how that looks. All of, 1, 2, and 3, those will be exactly like this first group here. So when you have 1 on the top of your fraction that is your exponent, those are always just going to be written square root of a, and whatever the denominator is, that's your index. So for number 1, we have x to the 1 over 4. So we're going to rewrite x under a radical. That exponent, or that denominator of 4 in our exponent, just tells us that that's the index for this square root. What's actually, I guess, a fourth root. Now, let's look at number 2. So we've got 15n. That's going to go under our radical to begin with. Then that exponent, or that denominator of 2 in our exponent, tells us that this is a radical with an index of 2, and that is that's just a square root. And then the last one we'll look at is number 3. We've got 24 to the 1/3 power. So we're going to rewrite that as anything with a fraction exponent. It's usually going to be a radical. So the top of our fraction is 1, and the bottom of our fraction, or the denominator, is 3. So that denominator is our index. So we would rewrite this as the cube root of 24. So those are all pretty easy. They get just a tad bit complicated when you change that exponent to a fraction that is not just a numerator of 1. So we'll look at number 4. We've got 7 to the 2/3 power. So that's going to be 7 under a radical. Now, our denominator still is our index. So that denominator is always going to be our index. And now this 2 that is our numerator stays under the radical, and it makes 7 to the 2nd power. So a good way to just remember it is when you have a fraction as an exponent, the top of the fraction stays in the radical. So let's look at 5. So we've got k to the 7 over 2. So a good way to remember this is k is going to go under a radical since we have a fraction as our exponent. That 2 tells us what our index is. So that 2 is understood to be there, but we don't write it. And then that 7 goes with what's inside of your radical, and that is its exponent. And we could actually break this down a little bit more. We could actually reduce this down. So if we have k to the 7th, remember what we just went over. If we have a square root and a variable underneath it to an exponent, we have to take those exponents out, or the only way we can take those exponents out is if they're grouped up in groups of 2. So 7 can be grouped in 2 in 3 ways, or I guess there's 3 groups of 2 within 7. So k to the 3rd would come out of the radical, and then 1k would remain inside of the radical. A good way, like I've told you before, k to the 7th is the same thing as k times k times k times k times k. So we can take one group of 2 out. We can take another group of 2 out. Then we can take a third group of 2 out. That means k to the 3rd comes out of the radical, and this last k stays inside of the radical. So that's really all this is saying when we're reducing them. But when they're written as a fraction, you've got 2 options. You can either you'll either have a setup like this first box here or the bottom box, and those are the 2 ways you would get. So now let's look at doing the opposite of that. So the opposite of that would be writing them in exponential form. So the first way we just wrote this was these answers were written in radical form. That just means they have a radical in your answer. If you want them in exponential form, your answers are going to be rewritten with an exponent in your answer. So say that we're looking at number 10. We've got 16, the cube root of 16. So we know we're going to have 16. Anytime that number is not to a power in our under our radical, that usually is always going to tell you your numerator for your exponent is going to be 1. And then your index tells you the denominator. So if we wanted to rewrite the cube root of 16 in exponential form, it would be 16 to the power of 1 over 3. Now, I think the rest of these you'll probably be able to get pretty easy, but we'll just go through them just in case. So like on number 11, we've got x, y, the square root of that. So we know we're going to have x, y. Those aren't to the power of anything. So they are going to be, which I usually put these in parentheses. So we know we're going to have it to the power of a fraction with the numerator being 1. And the denominator is going to be 2 because if it's just a square root, it's understood that the index is just 2. Now let's look at number 13. So on number 13, we've got a little bit of a difference here. We've got x squared under our radical or 11 squared instead of just 11. So if it were just 11, then we would rewrite this as 11 to the 1 over 3. But our 11 under our radical is to the exponent of 2. So that becomes our numerator, and our denominator is still that index of 3. So on number 13, the cube root of 11 squared, we would rewrite that as 11 to the 2 over 3. 14 would be rewritten the same way. We would have k to the power of 5 over 4. So this 5 that's our power inside of our radical is our numerator for our fraction that's written as our exponent written as a fraction. And our 4 is our index, so that's going to be our denominator. Now, don't get confused on problems like 17 and 18. Since there's multiple different multiple different variables under the radical, all we do is take all of that out and rewrite it as, which I'll do number 18 because it'll look a lot more clear. So all you do is take 9, x to the 7th, y to the 4th. You take all of that out of the radical, and it would be to the exponent of 1 over 3. Because all of those, when you have them grouped up like that, or multiple different ones, you're just going to take them out and act like their numerator's just 1. So don't get confused on that. Now we're going to look at simplifying and then writing these in radical form. So you're going to have to remember your rules for exponents, and that's kind of why I broke this up into 2 separate sections. So our rules for exponents tell us a couple things. When we're multiplying 2 variables with exponents, we add our exponents. When we have a power, like in 22, we're going to actually multiply these exponents. And when we're dividing variables with exponents, we subtract those exponents. So you'll have to remember those rules. But other than that, I think you should be okay with these. So for 19, we've got x to the 1/3 times x to the 4 over 3. So essentially we're saying x to the 1 over 3 plus 4 over 3. Because when we multiply 2 variables with exponents, we add those exponents. So that will give us, let's see, x to the 5 over 3. And if we want to rewrite this in radical form, we would take our x, put it under a radical. Our numerator is 5, so that 5 is going to go under the radical. And our denominator is 3, so that's our index. The only thing you've got to watch for is sometimes these can be simplified, and in this case, it can be simplified because we have an index of 3. That means a cube root. If we want to take out any of these x's, we got to group them up in groups of 3. There's one group of 3 that's inside 5. So another way to look at this is x times x times x times x times x. There's one group of 3 here. That's going to give me x. And then the rest of this would just stay inside of the radical. So I pulled out x, but then what's left in the radical is x squared. So your final answer would be x times the cube root of x squared. That's pretty much what you're going to do for all of these. Just make sure to remember when you're dividing or when you're adding or subtracting fractions, you've got to have a common denominator to do that. So that may be the only thing that trips you up. I'll do another one just real quick. I'll do a power rule for you. So we've got a to the 1/3 times, or it's a to the 1/3. All of that is to the exponent of 5 over 3. So essentially what we're saying is a to the 1 over 3 times, let's see, let me erase, a to the 1 over 3 times 5 over 2. So that's going to give me a. So when we're multiplying these fractions, we don't need a common denominator. So 1 times 5 is just 5. 3 times 2 is just 6. So then if we want to rewrite this as a radical, it would be a under our radical. Our denominators are index, which would be 6. And then our exponent on the inside of our radical would be this numerator of 5. So your final answer would be the 6th root, I guess you would say that as, of a to the 5th, which we can't do that. So all of that would stay on the inside. But that's really all we're going to go over. We'll go over more examples on our Google Meet, but that is it for this video.